Ex5A. Here we go. This is called distributive law, which you may have seen, expanding double brackets. You do A times the D, so we say AD. Then you do A times the C, which is AC. And then you do B times the D, which I'll write it again, is BD. And then you do B times the C. So we say plus BC. Okay, I'm going to show you all the logic to what this rule is, how do you apply it, etc. But right now, just write down the rules. Then you have perfect squares expansion. This, at a year 11 level, this is how I can tell how strong a student is when they first come in day one. Okay? This rule, when you multiply the brackets, notice the numbers are the same. So A, and then B and B. You don't have to use distributive law to do it. There's a shorter way of doing it, and this is your rule. A squared plus 2AB plus B squared. The alternative rule to this is, because A and B are the same, you can actually simplify it to say A plus B all squared. This is why it's called the perfect squares expansion, because this is a perfect square. I'll explain what that is visually soon, what a perfect square means. But that's the rule. So A squared plus 2AB plus B squared is a very useful rule. It is expected by the time you're in year 12 that you know that like your times tables, and you're meant to expand these brackets like that, not the distributive law. Distributive law is for junior. That's year 7, 8. So you guys in the Accelerate class, you may have already done that skill. It is expected by the time you're in year 9. Okay? And then that's how I can tell. So at year 9, if students still can't do that properly for the first rule, then I know their algebra needs a lot of work. Then I push you guys to these two, and that's what we're going to practice today. Okay? So perfect squares expansion and difference of perfect squares are the two that I want you to learn today. Difference of perfect squares, here's the rule. If you have A minus B and the other bracket, you're multiplying to the other bracket, and they have the same numbers but different signs. So notice one's minus and one's plus. So I'll highlight it. One's minus, one's plus. Then you can actually write it as A squared, so that's a perfect square. Difference means minus, and then B squared. So that's why they call it the difference of perfect squares, because they're both perfect squares and they're the difference of one another. Copy those rules down, and I'm going to show you the visual aspect of this so you can see where the rule comes from. Because there's one part that you're just doing algebra, and then there's another part where there's a visual geometrical explanation. Flip over to the next page once you have copied the rules down. Flip over to the other side, because you've got a blank side. Let's go with the first rule. So you had A plus B times D plus C. We said the rule was AD plus AC plus BD plus BC, right? Let's look at this visually. All of this, when we're doing quadratics, often we relate it back to a square, because that when you do to the power of 2, that square, the language in itself, we like the picture of a square. So watch this. Here's a square. Now what you're saying is you've got A plus B on one side. Now it could be a square, it could be a rectangle. We don't know yet. That's why it's not called a perfect squares rule. This is called a distributive law because we don't know if it's actually a square. Reason why is because it could be, so let me draw a rectangle because we don't know if it's a square. Let's say A to this point, that's the length of A. Then that means when you say A plus B, this length is A plus B now, hypothetically. Okay? So if I do that, I'm just going to cut it down. So you can see this is a length of A, and this is also a length of B. Then you write another bracket, and you say times, because in between the brackets means times, right? So you're timesing. Now the other one is D plus C. So I don't know how long D is, but let's just say D was maybe this long. Then that means D plus C, this must be C, hypothetically. If I do that, then cutting across, this side should also be D. This side should also be C. But what you can see is the rule in itself actually just describes the area of a rectangle, or this, whatever these two lengths multiply. Because when you say a plus b, which is this length, times by d plus c, you're just doing length times width. So it should give you the area of that shape, right? So we can see here, well, let's look at the area. This area here is a times d, because that little small area there, that's length of a times d, that's your AD. That's what this represents. So that AD there is just saying that corner area. Then you follow the same thing with the next one. You say, well, this area here would then be b multiplied to d. That gives you this area, which is what this represents. So far, we've got AD, we've got BD, and then you can see that on the bottom here, that would be A times the C, AC or CA, and that represents this one here. And then finally, the green section, which I'm going to color in green, this is C times B or B times C. So when you write the expansion, what you're actually doing is you're finding the area of those two lengths. That's what it is. So why is the next rule called a perfect squares expansion? By the same concept. This case, we do know it's a square now, and it's a perfect square because you said it's A plus B. So by the same concept again, A could be this length, B could be this length, but because it's exactly the same for both sides, this is also A, this is still A, this is B, this is A, this is B, and this is B. This is why we call it a perfect square, because technically all sides are the same. That's why the rules call it a perfect squares expansion. And as you notice, as you expand the brackets, it ends up being exactly what we have. A squared. Now, I know I gave you the rule before. I said A plus B squared gives you A squared plus, what was the rule again? 2AB. Good. You're going to get used to this one. Okay, I want you to memorize that. So, where's that 2AB coming from? Notice that these rectangles are going to be exactly the same, the one I'm coloring in blue right now. That is the length of A times B, and this is also the length of A times B. It doubles up because they have the same symmetrical length. They're actually symmetrical on a horizontal length. Oh, sorry, on a diagonal length. So if you cut it this way, notice they're both symmetrical. So that's B, this is B. That's A, that's A. So whatever this area is, that should be the same area as that. So you always double it. Okay, so in a perfect square, unlike this one, we don't know if that's a perfect square because all lengths are different. But here we do know all sides are the same. So visually, it makes sense why we double it. Okay, so that's why it's double whatever those two sides. And the last one is B times B, which is B squared. What I'm showing you right now on a visual aspect is what I'm also going to show you how to factorize quadratics, because you're going to use that technique. Okay, so quadratics will rely on visualizing this or doing another method. Okay? All right, last rule. You had A minus B times A plus B. I gave you the rule as A squared minus B squared, and this really was just simply from after doing a distributive law. If you do the distributive law, you'll realize it actually just simplifies down to A squared minus B squared. I gave this to you last term when we did rationalizing denominators. Yeah, so I'm going to show you again why the rule works. Here we go. Distributive law says you do A times A, so it's A squared. A times B, it's AB. Negative B times A, and that's where the key part is. That minus sign is where it changes everything. So negative B times A is negative AB. And then negative B times B gives you minus B squared. Because B times B is B squared, and then negative times positive is negative. What you see there is that AB and negative AB cancels out. That is why they came up with this rule. And on a visual aspect, this is the same thing as saying a perfect square of length A by A, take away a perfect square, which is obviously smaller, B by B. And you can actually draw it out. If you want to test it, you can also draw it out and do an A, and this is a plus B, and then minus B. If this is the length of A and this is the length of B, you can draw B a bit less on one side, so then it's smaller. Okay, and then you can see how it's like A minus B, same thing. Okay, but that's just what I wanted you to have. So that's just the theory. Okay, so you got distributive law, year 7, 8, technically 9 as well, but you guys are in the advanced class, so we're now going to consider year 10. The next one is perfect squares expansion, which is this one. I want you to get really familiar with this. So I'm going to practice with you to show you how to do this fast. And I need you to learn this skill. A squared minus B squared can start easy, and I can make it really hard. Okay, so I'll show you the variety of examples on how I can take this simple rule and then show you the variety of differences that you can do. Okay, some of which you will start needing to use certs. So here we go. Let's go back to our notes. Let's go back here. Did I put some of the examples in? No, I didn't test you too far. I'm going to do it later. All right. Let's do some examples. First one, some year 7, 8 maths. First example, you want to expand and simplify. Can I please have, let's go with Jaden. How do you expand the first one? What do you do? Good. Very good. That's what you would have learnt in year 8. It is negative 2 groups of x and negative 2 groups of 4. So we write out negative 2x plus negative 2 times 4 is negative 8, which you can actually just write as negative 2x minus 8. So that is what you would have done year 7, year 8 to learn, which is to expand and simplify, collecting like terms. Okay, so that's the first step. Next one. I test my year 8s on this to see if I catch them with a mistake. Let's see if you guys get this wrong or right. Have a go with this one first. I'm going to give you 60 seconds. Let's go. And I want to see how many is going to make this error. How many is going to make this error? 60 seconds. Let's go.
Wait, what did you guys get?
Yep. Were you here last week? Then you should do it. It's to help you understand the visual aspect of it. So watch my videos. Otherwise, if I have time today, I'll drop by over and I'll show you. All right, let's check our answers. Most people will get the first bracket right, nothing wrong. Most students would write 5x squared unless you did x times x and you got that one wrong. So 5x times x is 5x squared. Minus 1x, which most of you should get right. It's the second one. Be careful with that negative. It's negative 2 times 3 minus 6 everyone gets. It's the next one. Minus 2 times minus 2x is not negative 4x. It's actually plus 4x. So if you didn't get that plus 4x, your answer will be different here. You have the 5x squared. You have the minus 6. But then that minus x plus 4x, you either have 3x or you had negative 5x. Hands up if you have the correct answer, which is what you see up on screen. Okay, good. So the mistake with the year 8s and year 9s, that negative. Okay, that double negatives. Very good. And you can't add them because they're all different terms. One's an x squared, one's a constant term, and one is an x, so you can't add them. So that's it. Next one. Distributive law. X times x times 5, 2 times x, and then 2 times 5. Can't get this one wrong if you take your time. Should you get x squared plus 5 times x plus 2x plus 10? Everyone got x squared plus 7x plus 10? Good. Now, here I'm going to do a bit of practice with you. This is a perfect square. Your fourth example. Eyes and ears towards the board, thank you. Thank you. I don't want to see students do this. Don't do that. That's how I know. By the time you're in year 11 and I give them this problem, pretty much day one, they come in, like orientation day, and I look at their steps. See what I mean? I don't care about the answer. Everyone gets the answer. But I'm interested in what they did to get there. Students that I see that do this, I know straight away 9 and 10, their algebra is very mediocre or average, and they may struggle with methods. But that is the first step that I see. What I want to see, to know if a year 10 student moving to year 11 methods, can they handle methods, is if they straight away told me what the answer was, which means they would have gone through the steps here. They would have done x squared. Very good. Remember the rule was a squared plus 2ab plus b squared, yeah? So first one is you square the first number. So a squared, square the first number. So you should get x squared. 2ab means a times the b and then double it. So x times negative 3 is negative 3x. Double it. So it should be 2 times x times negative 3. You should get negative 6x. Plus, last one was b squared. So you square the last term. So the last term is negative 3. Square of negative 3 is plus 9. So at that year 11 level, when I see a student jump from there to there, I know they know the rule. Students who show me the steps, I know they're meticulous. Students who show me all three, then I know all two, then I know that they might have potential based on their analytics or they're just hardworking. It's one of the two. Okay, but that's how I tell a lot from your working solution. And obviously, if it's messy and it's all over the place, then I know you're struggling in maths. Okay, or you're just intuitive. It's one of the two. Here we go. Let's do some examples now. I want you to quickly tell me. Well, write down your answers here. I want you to expand using the perfect squares expansion rule for x minus, let's go with 9, 2x minus 1, 3x plus root 5. Okay, 3 examples. I want you to use the rule I just gave you. So I'm showing you how you can take one rule, one example that you do, and how I can then start to increase the difficulty. That last one is a typical one that you can easily do at year 11 methods, but that's how I know how strong your surds are, how strong your quadratics are. Are you doing the distributive law or actually using something new? So what is the answer for all three? I want it to be like that. You should be looking at that and writing down the answers. But as you're practicing, it's okay to take a bit of time, but eventually that's the speed I want you to get to. So you're going to look at it and just tell me what the answer is for each one. So follow the rule, square the first term, take the first and second, times it to each other, then double it. And the last one is square the last term. So square the first, square the second, and the middle one is just times them together and double it. Here's the answer for the first one. Square the first, square the last, times the 2 together, so negative 9 times x, and then double it. Hands up, who got the first one correct? Good. So square the first, square the last, times the 2 middles, and then double it. Have we go with the second? Second one, students can make a mistake if they don't square correctly, but the answer should be square of 2x means 2x times 2x is 4x squared. Square the last one is plus 1. Times the 2 together, 2x times negative 1 is negative 2x, and then double it. You only times it once. So 2x times negative 1, and then you double it. Yeah, because it's 2ab. So whatever a is and whatever b is, times it together, double it. Hands up if you got the second one correct. Okay, we're seeing a bit less. It makes sense. Either you haven't done it or you made a mistake. But that's what I mean. I'm increasing difficulty. Have a go with the third one. Try not to make a mistake. And the last answer. 9x squared. Square the first one, so 3x times 3x is 9x squared. Square the last one, so root 5 times root 5 should just be 5. And then times the two together, 3x times root 5, which is 3 root 5, and then double it, becomes 6 root 5x. So the middle one, 3x times root 5. So 3x times root 5 is 3 root 5x. Double it means you times 2 to the front. 2 times 3 root 5x, so it gives you 6 root 5x. Okay, so you're not going to get those kind of questions, but I'm showing you how you can take your understanding a bit further. Yep. Oh, that's fine. Yeah, 6x root 5, that's fine. Yeah, we normally do number first before letters. Yeah, so that you know what the coefficient of x is. No, I just know that your algebra is not fully there yet. That's how I know. Because the orders matter. Because the orders matter. When you write x squared x, it tells me the number in front of it. But if you're mixing it all up, then I know. I just know how strong they are. That's it, based on layout. You'll never see a teacher do that. That's what I'm saying. So, good enough to teach you how to do it. We're not mathematicians, but we can tell. If ours is like minimum, then you guys can be better. All right. Next one. All right. Last rule, team. So this one, I find that my year 10s, difference of perfect squares, my year 10s and my year 11s really struggle to get it the first time. So let's see how fast you guys pick up on this. The first one's easy. Like the examples in textbook, you'll definitely smash through. But as I change it, I want you to see what I'm doing so that you can learn the skill. Don't memorize, learn the skill. So here we go. I gave to you before. I said a minus b times a plus b is equal to a squared minus b squared, right? So what we can see here, this is my a. They both have an x. That's my b. They both have a 7. The only difference between them, one is a plus and one is a minus. So according to the rule, you can say it's the square of the first number minus, because I'm following, minus the square of the second number. So most students will get this. No problems, right? So I'm going to do some examples, and you're going to do it in your head. You can tell me the answer, okay? So here we go. Here we go. X minus 3, x plus 3 equals? X squared minus what? 9, yes. If I gave you x plus 4, x minus 4? Okay. Let's up the ante a bit. Let's see if you still pick it up though. So, what if I change it now to AB minus C, AB plus C? Wait, say it again. Well, I'm hearing a lot of different things right now. Yes. Very good. I don't want to see, when you say AB squared, the problem here is it may sound like this. That's not right. It could be, it's AB all squared minus c squared, which really just means a squared b squared minus c squared. Okay, so just be careful there. All right, now let's push it. So this is when you first learn it, year 9s. And then here, they don't normally get it unless you do reasoning enrichment. Then I move to year 10. So year 10, they increase it a bit and they do this. I'll do another color. Very good. All right, let's up the ante a bit. So this is to me, this is what we go through. This is year 10. We start practicing where it's not single coefficient. Let's move up a bit. What if I changed it to Very good. Okay, good. We're picking up. Square the first minus the square of the second. So square root 2 is 2. Square of x is x squared. And square of 3 is 9. Subtraction. They're all minusing. All right. Next one. That's year 10. The skill that eventually that you want to learn is going backwards. Okay? So you've been going forwards. Backwards is what we want to do. So I'm going to go backwards now. I'll do green. All right, here we go. Let's go backwards now. So you were able to go forwards. Backwards is the skill that they want you to know. So here, let's try 16x squared minus 25. Okay, good. Very good. 4x minus 5 and 4x plus 5. Very good, you're picking up. Now, that's actually really good. So that's the year 10 level. That's what you practice. Okay, most of them will just try to learn that. Now, here's a typical one that I start off at year 11 that I go to see how far they have understood difference of perfect squares. All right, let's see. So this is the starting one. So I start now doing... I'll keep it simple. I'll keep it 9. I'll keep it simple. But I can make that a bit harder, but we'll just stick with that.
Oh, I've seen it. It's a 3. Yeah. Okay, it's x. What are we?
So I want you to go backwards. So what you did...
It's either x.
Yeah. I want you to go backwards.
Oh, it's x minus.
Because you were able to do x squared minus 16. Or x squared minus 9. All I did was I just changed it a bit. So you did that one. I want this one. Write your answers first. Write in your book. And then write the answer. So far, so good. The fact that you can do the first one, if you got the first one, that's really good. You don't need to for this year level. So at this year 9 accelerated level, what you learned before was okay.
We split up the square.
You don't have to. It's just pushing it. You can. Challenge. You can if you want to. I just. In fact. Maybe I could say let's y equals an x.
Why you can